Welcome. This video provides worked out solutions for the MAT M1 Final Exam Practice Problem, Set A. Your feedback is encouraged. You can email mlitwack@kingsborough.edu with comments and/or suggestions. Now please keep in mind that most problems in math can be solved in multiple ways. The methods chosen here may therefore be a little bit different from those used by your instructor. This is normal and to be expected. So if you already fully understand how to solve a particular problem type, you should probably stick with it. On the other hand, if you're having difficulty with a particular problem type, this video will hopefully help you understand it better. Most of the problems in this video are solved in one way in order to avoid confusion, but occasionally more than one solution is provided in order to elucidate a clearer understanding of an important concept. So good luck, and let's begin. Problem number 1 asks you to divide. There are 3 division symbols as you see over here. The first one is the standard division symbol. The second one is the long division symbol. And the third one is the fraction bar. Now in this particular problem we're dividing 2 decimal numbers and we're going to have to do it by long division. The second number, the 0.08, must go on the outside. So we'll do 0.08 into 9.6. Now you cannot divide when the divisor, the number here on the outside, is not a whole number. The way we make it into a whole number is by moving the decimal point sufficient places till it then becomes a whole number. So if we move the 0.08, move its decimal point twice to the right, we're left with 008, which is the same as 8. The number underneath the division sign will also have to be moved that same number of places. So then we can rewrite this as 8 into 960. Now the reason it's 960 is because you move the decimal point 1, you run out of places, so you need to insert a 0. And then we begin. How many 8's in 9? 1. 1 times 8 is 8. You subtract, and you bring down the next digit. And repeat the process. 8 into 16, 2. 2 times 8 is 16. Left with 0. Bring down the 0. How many 8's in 0? 0. So we're done. The final answer is 120. Question number 2 asks you to multiply 2 decimal numbers. The steps will be to multiply, ignoring the decimals for the time being, and then insert the decimal in the correct position. I suggest you multiply vertically because that's easier for most people. Now the order in which you multiply does not matter, but I suggest this time you multiply the 5.37 first. The reason being that there are only 2 digits to multiply in the 0.029, since you don't have to multiply by 0, since 0 times any number is just 0. Now I strongly suggest, if you haven't already, knowing the multiplication tables really well, because if you get them wrong, obviously we don't want that, but if it takes you too long, that's also not going to work for you. You'll run out of time. Also, as we carry, we'll be carrying as we multiply by 9. When we get done with the 9 and we go to the 2, I'm going to erase the carries for the 9 so we don't get confused when we carry for the 2. So 9 times 7 is 63, carry 6. 9 times 3 is 27, and 6 is 33. Carry 3. 9 times 5 is 45, and 3 is 48. Now we'll multiply by the 2. 2 times 7 is 14. Also, you notice as we multiply each successive digit to the left, we have to indent one column. That's why the 4 is under the 3. So 2 times 7 is 14, carry 1. 2 times 3 is 6, plus 1 is 7. And 2 times 5 is 10. We add up these numbers, and we get 3, 7, 8 and 7 is 15, carry 1. 1 and 4 is 5, 1. Now is when we have to pay attention to the decimals. Now in the first number we multiplied, we had 2 decimal positions. In the second number we multiplied, there were 3 decimal positions. So in all, we have 5 decimal positions. Therefore, we're going to have to move the decimal 5 to the left. Now when you don't see the decimal, it's all the way to the right. So after we move it 5 to the left, it'll be 1, 2, 3, 4. It'll wind up right there. So the final answer will be 0.15573. Now they also might write it like this, with a 0 in the whole part of the number. Either way is fine. They will not give you both because you cannot have 2 correct answers on a multiple choice test. Here they left out the whole part of the number, so it's obviously nothing or 0, and here we wrote it. In problem number 3, you're asked to divide 2 fractions. In this case, both are mixed numbers. A mixed number is something that consists of a whole part and a fraction part. We see 4 and 5/6, for instance. 4 is the whole number, 5/6 is the fraction part. And an improper fraction, as we'll see soon, is a fraction in which the numerator is greater than or equal to the denominator. That symbol there is the greater than or equal symbol. So to divide fractions, step 1 is to convert mixed numbers into improper fractions. So let's do that right now. We have 4 and 5/6. We have 1 and 7/18. We need to convert both of them to improper fractions. So what you do is you multiply the 6 times the 4, and then you add in the 5. So we'll get 6 times 4 is 24, plus 5 is 29. Divided by the denominator we have. Divided by 18 times 1 is 18, plus 7 is 25 over 18. Step 2 is we change the problem into a division problem, into a multiplication problem rather, and we flip the second fraction. Next, we multiply the fractions together. Now, when you multiply fractions, you multiply the numerators together, you multiply across, and you multiply the denominators together. Rather than doing the multiplication right now, I'm just going to indicate it. So the numerator becomes 29 times 18, and the denominator is 6 times 25. Now the reason why I delay the actual multiplication is because if we have to multiply, we can always do so. But by delaying sometimes, the numbers you would actually have to multiply or divide will be smaller, which is to our advantage. What I'm going to do now first is cross out. Crossing out will make the actual multiplication division problem easier, as I said, because the numbers are smaller. So we know that 6 into 6 goes 1. 6 into 18 goes 3 times. So at this point there's nothing left to cross out. So we get 29 times 3, which is 87 on the top and 25 on the bottom. If you're not sure why 29 times 3 is 87, pause the video for a moment and multiply it out. The last step is to convert our improper fraction into a mixed number. Probably that's the form they're going to want it in, since the problem was given to you as a mixed number. So to convert an improper fraction to a mixed number, you need to perform long division. So what I'll do here is I'll place 25 on the outside, 87 inside, and now we'll divide. 25 is an easy number to divide by. 25 and 87 will be 3. We'll get 75. And when we subtract, we get 12 as a remainder. So our final answer will be 3 from the quotient area here. The remainder is the numerator of our mixed number, and the denominator is our divisor. So that is our final answer, 3 and 12/25. So let me circle that. The final answer is 3 and 12/25. Problem number 4 asks us to multiply 3 fractions. As we saw in the previous problem, we multiply fractions by multiplying the tops together, the numerators together, and by multiplying the denominators together. So let's do that. We get 8 times 11 times 26 in the top, 13 times 24 times 33 in the bottom. Now you could multiply 8 times 11 times 26, that would be a mess, as well as multiplying the numbers in the denominator and then do a long division. But I think you know where I'm heading with this. I'm going to cross out first if I can. And it turns out real nicely. We see 8 into 8 goes 1. 8 into 24 goes 3. 11 into 11 goes 1. 11 to 33 goes 3. 13 into 13 goes 1. 13 into 26 goes 2. So all the large numbers are gone in this case. So in the numerator, I have 1 times 1 times 2, which is 2. And in the bottom, I get 1 times 3 times 3, which is 9. So the final answer is 2/9. Problems 5, 6, and 7 deal with rounding. The purpose of rounding is to reduce the number of digits. That is, to chop off digits at the rightmost part of the number. The result is less precise, but more readable. So in each problem, you'll be given what we call the round-off digit. The round-off digit is the rightmost digit to keep. So in problem number 5, you see that they want you to keep to the nearest tenth and no further. In problem 6, to the nearest hundredth and no further. And in problem 7, to the nearest thousandth. Now, in order to round properly, you need to know what the tenth, hundredth, and thousandth columns are, where they lie in the number. So what I've done is copy a place column chart into the video that you're now seeing. It may be a little blurry, but I'll walk you through. The columns are actually symmetrical. Let me tell you what I mean by that. Here you have tens. Here you have tenths. Here hundreds. Here hundredths. Here the thousands column, and here the thousandths column. And that should make it easier for you to memorize which column contains the round-off digit. Now the way you round is by looking at the digit immediately to the right of the round-off digit. If it's greater than or equal to 5, then you add 1 to the round-off digit. So in problem number 5, we have 50.7018. The round-off digit is going to be tenths. So we see that tenths is one column to the right of the decimal point. And now we ask ourselves, is the column to the right, is that greater than or equal to 5? And since the answer is no, we leave the round-off digit alone, and the final answer is 50.7. In problem number 6, they're asking us to round to the nearest hundredth. Looking at the place value chart, we see that is 2 columns to the right of the decimal point. So the round-off digit in this case is going to be the 4. So we look at the number that's to the right of the 4, and since it is greater than or equal to 5, we need to bump up the 4. So in this case, the final answer will be 19.05. Remember, we're only going to keep 2 digits here to the right of the decimal point because they're asking us to round to the nearest hundredth. In problem number 7, they're asking us to round to the nearest thousandth. And by looking at the place value chart, we see that that represents 3 positions to the right of the decimal point. So that will be the 0 here. So the question is, do we bump up the 0 or do we leave it alone? Well, since the column to the right of the 0 is greater than or equal to 5, we bump up the 0 to 1, and this is the final answer. Now there's one special case of rounding, and that's when the round-off digit equals 9. So let's look at an example. Round 8.9 to the nearest tenth. You'll notice here that 9 is the round-off digit, but there's nothing larger than 9. 9 is the largest digit. So what we do is what we did before, but we just make this into a formal addition problem to make it work out properly. So once again, we will add 1 to the round-off digit, and you see that when we do so, we'll get 9 and 1 is 0, carry 1, 1 and 8 is 9. So the final answer is 9.0. Problems 8, 9, 10, and 11 are percent word problems. There are many different variations you'll find on the internet or in textbooks that your instructors use, but they basically fall into 2 methods. The first method being formula and the second method being proportion. We'll do problem number 8 using both methods, but for the remaining problems we'll choose the formula method. The formula method is P times W equals R, where P is the percent of the whole. The whole is usually what you start with. W is the whole, and R is the resulting part after applying the percent to the whole. And it's also very important that P and R refer to the same quantity. We'll see that in problem 11. So problem number 8 asks us to find 14% of 650. So I'll write the formula. What I usually say to my students, okay, Let's power it up. So we have P times W equals R. And now we substitute. P is the 14%. Now, you could use 14%, but it's much easier in math to convert a percent to a decimal before you use it. And the way you convert a percent to a decimal is by moving the decimal 2 to the left. So we'll do that here, and we'll write 0.14 times W. Now W is the whole thing. It's the original amount. So that's 650, and we're going to have to solve for R here, the resulting part we're left with after we apply the percent. When you have doubt, remember it's always the percent of the whole. So when it says percent of 650 here, it means percent of the whole. If you multiply 0.14 times 650, you get 91, and that is the answer. If you want to see how I got 91, I'll show you now. I multiplied 650 times 0.14. And you see that the 0.14 has 2 decimal positions, so the final answer will have 2 decimal positions. And now we just multiply. 4 times 0, 4 times 5 is 20, 0 carry 2. 4 times 6 is 24, and 2 is 26. Now we multiply the 1 times 650, indenting. 1 times any number is the number, so that comes out just to be 1 times 0 is 0, 1 times 5 is 5, 1 times 6 is 6. Adding, we get 0, 0, 6 and 5 is 11, carry 1, 6 and 2 is 8, and 1 is 9. Moving the decimal over 2 positions, remember it starts at the rightmost, if you know, at the right end if you don't see it, gives us 91.00, which can be written as 91. So that is the final answer. Now the reason we can get rid of the zeros there is because they don't contribute value to the number. 91, adding into that 0 tenths and 0 hundredths, does not change the value. So we'd like to write the number in the most simple way possible. A good rule of thumb to use is, when you're trying to determine whether you can delete zeros, is if in doing so none of the non-zero digits move, then you know it's okay to remove those zeros. Now for the proportion method, we write x over 100. Now remember that the definition of a percent is some number over 100. The percent of something is what part of it we're interested in. So the right side here is going to be part divided by the whole. So since x over 100 represents a percent, we can plug in, since they told us the percent. So we'll plug in 14. Now you don't want to play the decimal game that we did when we used the formula, the power formula, because here 14 over 100 is a percent, 14%, and that's what they gave you. Now they told you percent of 650, and since it's always percent of the whole is 650, which means we need to solve for the part. Now rather than using P for that variable and possibly confusing us with percent, let's use a variable we have not used yet. So I'll use Y here. Now we have a proportion that we need to solve. And one of the principles in math is that you can solve a proportion by cross-multiplying. What that means is you multiply along each diagonal and set the results equal to each other. So in one diagonal I get 100y, and the other diagonal I get 14 times 650. I'll divide both sides by 100 because I just want y on the left, and after crossing out, that's what happens. I'm just left with y. And I have to divide the right side by 100 as well. Whatever you do to the left side, you have to do to the right side. Finishing up, we get 14 times 650 is 9,100 divided by 100. The two zeros cross out here, and you're left with y equals 91 over 1, and any number divided by 1 is just the number itself. So again, we get the same result as when we use the power formula. I'll leave it as an exercise to you to see that 14 times 650 is 9,100. Problem number 9. 216 is 24% of what number? 24% of what number? Percent of the whole. So let's power it up. The familiar P times W equals R. The percent given is 24%, so we'll write that as 0.24. The whole we want to find is 24% of what number is the result of 216. So we'll divide both sides by 0.24. And W will equal, well, we need to divide here. Remember, the denominator will go on the outside. So we'll need to move the decimal point over twice here, so there'll be 24. And since we move the decimal point for the 24 2 to the right, we'll need to move the decimal point of the 216 2 to the right, which means we'll need to add 2 zeros. And I'll place my decimal point, and at this point I don't know how many decimal places the answer will be, so I'll just write a few. So 24 into 216. Now 24 is almost 25, so you know the 4 25s in 100, and 8 25s in 200. We have a little bit more than 200. So let's try 9. I feel good about 9 because when I multiply 9 times 4, it's going to be 36, which ends in 6. And this is what I have in my dividend here, 6. So 9 times 4 is 36. Carry 3. 9 times 2 is 18 plus 3 is 21. So that's exact. And we subtract, we get 0. Bring down the 0. How many 24s in 0? 0. Bring down the next digit. Again, it's a 0. 24 and 0 is 0. So my final answer is 900. Problem number 10. A candy bar has 85 calories. 34 of those calories are from fat. What percent is this? So let's power it up. They're asking us to find P. Now, we do not see the words percent of a number in this problem, But we still can figure out the W because we know W is always the whole or the original amount. So we'll replace W with 85, which means that R is 34. Divide both sides by 85. The 85's cross out, and P will be 34 over 85. Now, we need to express the answer as a percent because that's what P represents. So in order to do this, we're going to have to get a decimal first by doing long division, and then after that, we'll convert it to a percent by moving the decimal 2 to the right. Now at this point I have no idea how many decimal places I need, so I'll just add a few zeros, doesn't hurt, and we'll align the decimal point. 85 into 34, there are none, so let's try 85 into 340. Now 85 is somewhat close to 100. We know there are 300s in 340, so certainly there are at least 3 85s in 340. Now if I were to put a 3 here, if I were to do that, then when I started to multiply, I would get 3 times 5, which is 15. So the last digit would be 5. And I know that it's possible that the answer could be 4, because I know that 300s fit in 340. I know 400s don't, but maybe 485s would. And if I do put a 4 here, 4 times 5 is 20. It does end in a 0, which is what I need, so let's try. 4 times 5 is 0, carry 2. 4 times 8 is 32, and 2 is 34. So that's exactly what we want. We have no remainder, and the answer is 0.4. And when we convert that to a percent, the decimal goes 2 to the right. We only have one position, so we'll have to add a 0. So the final answer is 40%. Problem number 11 tells us that the price of a jacket is $120. They want to know what is the sale price after the jacket is reduced by 18%. We'll begin by powering it up. P is 0.18. W is going to be $120 because that's the entire price of the jacket. And we'll calculate R. Now we need to be aware of what 0.18 represents here. 0.18 represents the reduction, the reduced percentage, which means that R must represent, as we said in problem number 8, R must represent the reduced amount, since it must always be the case that P and R agree with each other. So if we calculate R here, we have 120 times 0.18. It doesn't matter which number you put on top. I prefer the 120. So multiplying, you can follow along. 8 times 2 is 16, carry 1. 8 times 1 is 8, plus 1 is 9. So now let's multiply the 1. And 1 times any number is the number. We indent one place, so we get 120. Adding, we get 0, 6, 9, and 2 is 1, carry 1, 2. We see that we have 2 decimal places in all. So the answer has to be adjusted so that the decimal place is moved 2 to the left. So the final answer will be $21.60. That is the reduced amount, keep in mind. So now what we need to do is find the sale price. Well, you should be able to figure that out. If you know the reduced amount and you know the original cost, you should be able to figure out the sale price. So the sale price is going to equal the original price, or whole, minus the reduction. So we'll substitute the original price of 120 minus our reduction, and that will give us the sale price. Let's do that subtraction along the side here. So we have $120, which is $120 and 0 cents. We're going to subtract $21.60. Now when you're adding or subtracting, you need to be very careful to line up the decimal points. So 0 minus 0 is 0. 0 minus 6 we're going to have to borrow. Cannot do that. Cannot borrow from the 0, so we'll borrow from the 2. That will become 1. And now we bring a 1 here. We still cannot do our subtraction, so 10 will become 9, and you put a 1 here. So 10 minus 6 is 4. We'll line up the decimal point. 9 minus 1 is 8. We cannot do 1 minus 2, so we will borrow from the 1. That becomes 0. We'll put a little 1 here. That's 11. So 11 minus 2 will be 9. So the final answer is $98.40. There is an alternative way to solve problem number 11, but if you feel comfortable with the solution just presented, you can skip the alternative and go directly to problem number 12. So let's look at the alternative approach. If you remember, the price of the jacket is $120, and we want to know what is the sale price if the jacket is reduced 18%. The alternative approach lets us solve for the sale price directly. In other words, it lets us specify that R is the sale price and not the discount. Well, if R is going to be the sale price, then P must refer to the sale price as well. The problem is that they gave us the percent as a reduced percent, not the sale price percent of the original that you pay. But there's something we can do if we realize the following. If you look at the rectangle I've drawn here, the 100% over here represents the entire jacket price. Now, if they take off 18%, if the reduced amount is going to be 18%, then the percent you pay is 100% minus the 18%. So you wind up paying 82% of the jacket's original price, which equals 0.82. So we can use that in our power formula. So 0.82 times 120 equals R. And we know from before that the answer was $98.40. So we better get that now when we do the multiplication. So 120 times 0.82 with 2 decimal positions here gives us 0, 4, 8, and 9. With 2 decimal positions, the answer is $98.40, the same thing we had before. So I hope that helped. If you like this approach, you can use this approach. Otherwise, feel free to use the original approach.